All right. So when we're solving matrices, it's basically, I have to write this down. If it was 2x equals 16, you would go back and divide by 2 to solve, right? The problem with matrices is you're not able to divide by a matrix. So we have to get kind of creative on this one, that instead of dividing by something to solve for matrices, you actually have to multiply by an inverse. So basically we'll say it this way. If AX equals B, where A is matrix A, X is matrix X, and B is matrix B, that if you've got matrix A with numbers, X is the matrix you've got to find equals B, to find out what that is, you're going to basically multiply both sides by the inverse of whatever this matrix is that's multiplied by X that you're trying to find. So that if you multiply, and this is kind of what we were working on yesterday, that if you multiply a matrix times its inverse, they basically cancel it out and gives you the identity matrix multiplication. So in that case, to find matrix X, it's just A negative 1, which is the inverse, times B. Okay, so again, over here, what we were doing, this was given matrix A. Matrix B, and then matrix X. So if you got AX equals B, the first thing they have to tell you is that you're given matrix A, matrix B, and you got to find matrix X. We multiply by the inverse of the missing matrix, basically. All right. And again, the good thing with this one is that because we're not going into 3x3 matrices with this one, it's all going to be 2x2 matrix. So that will make this a little bit easier when we're going through and finding the inverse. Because again, if we go to 3x3, it makes it a little bit tougher. So this one, we're pretty much kind of going back and we're reviewing basically what we did yesterday. So for people like Jaden who wasn't here yesterday, this will be kind of a good tweak to go back and let you kind of pick up on a little bit of what we were doing yesterday. Okay, so they'll just tell you to solve for X. So let's go 4, 3, 2, 2. X equals negative 5, 2. Okay, and again, this matrix over here will wind up changing. It can be all kinds of different sizes, but because of where we're kind of putting our limits on what we can do determinant-wise, this matrix here will always be a 2x2. All right, so basically this is your A. Of course, we got our X here equals, that's basically matrix B. They don't really give it to you that way, but that's kind of what you want to think about. So what we've got to do is we've got to figure out what the inverse of A is. So we've got to find the A inverse. So for this one, for all these equations, it's basically going to be the same steps every single time. The first thing you're going to do is you're going to find the determinant of A. Okay, so we got to get the determinant first. So take the matrix, and again, this is the easy part of it. Just doing cross products, it's 4 times 2 for 8. And again, it's always minus, and then whatever this number happens to be. In that case, it's just 8 minus 6. So the determinant is 2. Okay. Am I okay with that now? All right, so step 2, to get the inverse, to get a negative 1, that's where we're going to do 1 over the determinant. And then we've got to multiply by. But again, for this one, what we've got to do is we've got to switch these two numbers and then change the sign of those two numbers. So again, this is basically what we were doing yesterday. To get the determinant, we did the cross products. That was easy. But to find the inverse, you do 1 over the determinant. And then for the matrix, you're going to switch these two numbers. And then you change your plus minus sign on those two numbers. So again, find the inverse. It's 1 over determinant. Switch these two numbers. Change the sign of these two numbers. Okay, and then you multiply that. And again, more than likely, you're going to get some fractions mixed in with these because it's always going to be. Now, unless the determinant happens to be 1. If the determinant's 1, that's great because it makes the math a whole lot easier. So if I do half of 2, that's 1. Half of negative 3, that's negative 3 over 2. Half of negative 2, that's negative 1. And half of 4 is 2. Okay, so there's the inverse matrix. So, and that's where we stopped yesterday, was finding the inverse matrix after we multiplied and did all the stuff with the determinant, switch the signs and everything there. So that would be the inverse. And then for today, we're going one more step. And we're going to multiply. Last step here. That to find x, and kind of what we said back up here, that x is going to be the inverse of a times b. So we're going to do the same thing here. We're going to find the inverse of a, which we got right here. And we're going to multiply that times matrix B, which was negative 5, 2. Okay. So today is just kind of putting everything together that we've done the last few days. Step 3. Got to put 3 there. Okay. And again, the good thing is with the multiplying on this one, the matrices won't be too awfully big just because of where we're kind of setting our restrictions on finding the inverses. So again, this is where we're just going to practice. It's the first row times first column. So that's 1 times negative 5, which is negative 5. It's negative 3 over 2 times 2. The good news is that case the 2's cancel. It makes that a negative 3. So that's negative 5 minus 3. That is negative 8. All right, and if you need to check size-wise on these, this is a 2 by 2 matrix, so we're good here. This one is a 2 by 1 matrix. So these match up, which is what we needed. The answer is going to be a 2 by 1 matrix. We're going to have 2 rows, but only 1 column. So basically, that's our first number there. All right, and then we're going to multiply this row by this column. So negative 1 times negative 5 is 5. 2 times 2 is 4. Makes that 9. And there you go. And there's your answer. Okay. And again, the good thing is that with this one, the first matrix that's with the x, because we're going to find the inverse, find the determinant, all the stuff with that one. It's always going to be a 2 by 2. If we go to a 3 by 3, it gets a little bit more complicated. So we're not really going to worry about that. We're going to basically leave that as a 2 by 2. So that's kind of the good news is that matrix that's with the x will never be bigger than a 2 by 2 for the problems we're going to do. All right, let's go ahead and do another one of those. Make sure we're good. All right, so for example 2. Let's go with 7, 5, 4, 3 times x equals -3, 0, 1, 4. And I'll get that out of the way so we're not getting anything confused there. Okay, again, I hate to sound like Dora the Explorer here, but there's 3 steps. First thing is we got to figure out what the determinant is. So that's 3 times 7. It's always minus 4 times 5, which is 20. And the good news for that one is 21 minus 20 is 1. So the determinant is 1, which makes the math a little bit easier when we go back and find the rest of this thing. All right, again, if you want to kind of have a layout of this one, this would be AX equals B for trying to figure out what the matrices are. So if this is matrix A, we're finding the determinant of A. So the determinant of A is equal to 1. Okay, for step 2, we've got to find the inverse. So we're finding A negative 1. And again, to get that part, it's 1 over the determinant. And then you take your original matrix, you switch these 2 numbers, and then you change your plus minus signs on those 2 numbers. Okay, so A negative 1 is it's 1 over the determinant, which in this case is great because that's 1 over 1, which means that's just 1. So we get a little bit of break on this one because once we switch these 2 numbers, that's 3, 7, these 2 numbers stay the same. We just have to change the sign of these 2 numbers. But when we multiply by 1, well, yeah, the great thing is it doesn't change anything. So the inverse is just that. It's 3, negative 5, negative 4, 7. Okay, again, that's where we stopped yesterday. And then today we're going to one more step and going back to what we did on a little bit of Monday, a little bit of Tuesday. Step 3 then is we're going to multiply the inverse that we just found, and we're going to multiply that by matrix B. All right, so that's going to equal the matrix we've got here, 3, negative 5, negative 4, 7. And we're going to multiply that by matrix B, which was this matrix back up here. So negative 3, 0, 1, 4. Okay, so here we go. If you're still working ahead, that's fine. I'm just going to go ahead and kind of follow behind you. All right, so when we're multiplying out, again, it's the first row times the first column. So that's the only problem with those doing it that way sometimes is that I couldn't tell if that was that's positive 3. Okay. So we got 3 times negative 3 for negative 9. Negative 5 times 1 for negative 5. So that's negative 9 minus 5. That's a negative 14. Okay, so then we're going to go this row times this column. So that's 3 times 0 for 0. Negative 5 times 4 for negative 20. So 0 minus 20 is just negative 20. Okay. And then for the bottom part, we're going to do negative 4 times 7, or negative 4, 7 times 3, 1. So negative 4 times negative 3 is positive 12. 7 times 1 is 7. So it's 19. And then we're going to do negative 4 times 0, which is 0, and 7 times 4, which is 28. So that's 28. So there's our matrix right there. If we put it all together so we can see it, it's negative 14, negative 20, 19, and 28. Okay. And every single one of these, again, it's always going to be 3 steps. First step is always going to be really easy. Find the determinant. We just do cross products. Make sure you go up and subtract in the middle. You've got to find the inverse. So then you're going to take 1 over that determinant, whatever that number is, switch these two numbers, change the sign of those two numbers, and then you multiply it out. Got lucky in this case that was 1. And at the end, you got to do the multiplication of those. So that, again, that ties in everything we've done except for the adding and subtracting part. That's the only thing we didn't do, which was the first half of what we did on Monday. All right, last example. And this is where you can actually like tie this thing together to help you solve some stuff. We're going to write a system as a matrix equation. And this is where it starts to tie back into, okay, where does this actually come in to do stuff with it? That you can actually take systems of equations and rewrite them as matrices to help you solve what you got to do. All right, I know it's been a little while since we did matrix or did equations of systems, but we'll go back and show you. So back in the old days, from like 2 months ago, we had this equation. And we were going to solve that system. He's writing on the board. Okay, to make this thing out to be a matrix equation, here's what we're going to do. We're going to pull out the numbers over here, the 3, negative 7, the 5, 1. And then to get that with the x's and y's in here, basically that's our second matrix of x and y. And then easy enough, that becomes our last matrix over here.